Hey guys, welcome again. Before proceeding, I thought that we should know about another protection uh, drawings terminology, protection engineer terminology, seal in contact. So, because seal in contact, I was preparing another lecture that was regarding anti-pumping relay, and in this layer there was one contact that we are calling it as a seal in contact. So I thought better explain you about this contact before proceeding to the video. So let's see what is it. A salient contact is a method of maintaining current flow after a momentary switch has been pressed and released. So the concept is, for example, the switch we know in our house is if you press the button it will become on, if you press the button again it will become off. So this is the switch we know, but seal-in contact is just like if I have an auxiliary relay. When I make a push button, the auxiliary relay will pick up. When I release that push button, the auxiliary relay will be reset. It means that this relay is not holding its state. So for example, if I want that if I make a push button, then it should pick up, but it should not reset until I press the reset button. So I should have now two buttons. One button is to make the contactor or relay auxiliary relay picked up, and if I press another button, the auxiliary relay or the contactor should be reset to the energized position. So with one push button energize, and it will remain energized even I release this button, and with another push button it's released. So what happened when I press a push button, what I am doing, I am using the auxiliary contact of the relay which is normally close contact to latch in and or seal in the position or the status of the contactor. So let us see how it's happening. So first just go through the theory quickly. Consider a relay is used to control the power supply to a motor. Here we are calling the relay as motor starter coil. The relay, another normally open contact, is used to seal in or latch the start signal that I was saying. A start push button is a push and release type, that is signal will be available for some time, say momentary, and then signal will be lost. Means it's like a pulse. So we have to latch this circuit in order to make motor run continuously even after release of start push button. So there is another term that we are using, that we need a latch circuit. It should hold its state. For this purpose we are using relay NO contact across start push button such that it will take care of start signal after start button is released. The seal in auxiliary contact NO contact of the starter M is connected in parallel with the start button to keep the start coil M energized when the start button is released. After start push button press, the motor starter coil energized and its NO contact become NC as shown in below figure. So this is the example of latching circuit. Means latch is the behavior of the circuit that is doing it, and this contact M is normally open contact of this starter coil, or you can say auxiliary relay, or you can say contactor. So if it is, I did not press the button, this is solid DC, as we are saying in our production terminology. This is solid DC or main DC is coming here. If I press the button, the DC will be passing through this and it is going to the motor starter coil, and this starter coil or this auxiliary relay is picked up through DC. When this picked up, energized, then this contact will become close, and now the circuit is sealed in through this contact. So this contact is called as a seal in contact. So DC is even I release this start button, this contactor starter coil will be keep on energized through this contact. Now this is close and it will be a latch. So if I want to stop this circuit, I will just press this push button. As soon as I press this button, then DC supply of this coil will be disconnected, or contactor will be disconnected. This contact will become open, and even I release it back, I close it back, the coil will not energize. So this is the concept of seal-in. So let's see the example. Now I have pressed this start button. Now this M is energized. If M is energized, this contact will become close. Once this contact will become close, even I release this, the circuit of DC will be through this and it will be keep on energizing. So this contact is called seal-in contact. This circuit is called latching circuit, and the relay we are using for the latch, we can call it a latch relay. The contact we are using it, we are calling it seal-in contact. Okay, this is the another type of way where you can show how the circuit is drawn. This is another presentation. Okay guys, now I have drawn a very simple circuit because the previous circuit was a little bit complicated in order to explain that how seal-in contacts are working. So here you can see I have a contactor, or I have auxiliary relay, and what I did, I used the NO contact of this relay. This is the NO contact of this auxiliary relay in parallel with the push button. So if I did not okay, so what will happen now? This is solid positive, this is solid negative. As soon as I make this push button, DC will be okay, DC will move from here. Okay, let me choose. DC will be moved from here to the relay through this switch. So now DC is moving here. When this coil is energized, when this push button is operated, so what I have done, I have closed this path. So now DC is coming here up the contactor, and it has energized the contactor. Now when this is energized, because this is NO contact, after when it is energized, this contact will be closed. So this contact here is closed now. Okay, now DC has two paths. One is through this, another one is through the push button, another one is from the NO contact of this relay or auxiliary relay itself. So even if I release this switch back, so now I decide that I am just releasing this switch back. I have put this switch back, I have removed this switch, but you will see that because this contact was energized already, so DC will follow still this path. So this will follow this path from here. Now the contact is closed, so it will follow, and the contactor will still remain energized even though I have basically take the hand from the push button. So this contact here, this contact is called as seal-in contact. Okay, so this is a seal-in contact, and if I push, if I want to reset, even I push this push button again on and off, it will not make any difference because the contact is picked up through its own contact, seal-in contact, which I have put in parallel with the push button. So if I want to disconnect the circuit, what I have to do, I have to break circuit. After this, what I will do, I will make another push button in series of contactor. So I will make another push button. Okay, I will install push button here. So if I want to break it, if I want to now break the circuit, I will push this button and then it will cut DC. Now, so okay, I have pushed it. I have pushed this button, it will cut DC. This contact will become open. So as this contact is become open, now DC is cut. So even I put it back, this contact is open, so there will be no DC here. So this contact will go back and this circuit is open now, even though I have take my hand off, but this will now remain in off position. So this was the concept of seal-in. So this will be useful in production theory. So I hope that you will memorize this concept. So we will then move to our new topic. Thank you very much.